my dear professors, it's me, Amal Mustafa Slim, and I'm gonna be with you today for this presentation to talk a little about the atomic force microscopy. Stay with us. The atomic force microscope is a high-resolution type of scanning probe microscopy that actually measures the surface structure in length scale from 10 nanometers to 100 micrometers with an affected resolution or accuracy. Moving to the basic principle behind the atomic force microscope is that it uses a sharp tip scanning over the surface of the sample while sensing the interaction between the tip and the sample that will result. The atomic force microscope provides different imaging modes that are known as contact mode, non-contact mode, and the tapping mode. Now, let's move to a little comparison between the three types of the operating modes. We got the contact mode where there is actual physical contact between the tip and the surface to be examined, while in the non-contact mode, as from the name, there is no contact between the tip and the sample, while in tapping mode there is an intermittent and short contact between the sample and the tip of the microscope. Concerning the contact mode, there is a great advantage that it's a very high speed scanning. Also, it gives a high resolution images, but it's actually not used easily with the soft samples because it can be destroyed with the scanning technique, and also the later forces that can be produced through the process can lead to image artifacts that can never be back. While in case of the non-contact mode, while it gives a great advantage that it can be used with any type of samples because it doesn't affect them or doesn't cause any damage to them, especially the soft tissue samples, but it gives a lower resolution image than the contact mode, and also it has a great disadvantage that it's lower in the scanning speed if compared to the contact or the tapping mode. Moving to the tapping mode, it's absolutely given a higher resolution image with minimal damage to the sample, which is given it an advantage over the non-contact mode. But also, it's a little bit slower than the contact mode if compared to it. But absolutely, it's faster when compared to the non-contact mode. In this sample, we just show you the result where we can measure the contact between the sample and the tip, where this can give a lot of information about this sample. Here we see how it works, where the control to the computer and then controller electrodes, where it's doing the sensing, detecting, and positioning, and then the laser through the photodetector, and then we get the data through the computer. Through this as well, the same technique or the same principle. And here to the left is the way it works, how it works, and B, where the intermittent contact or the tapping technique and contact and the non-contact differences. And here is another example showing the atomic force microscopic images of different dental tissues, enamel dentine and cementum, of extracted human canine, as you can see in the pictures. Now let's move to the actual uses of AFM. Actually, first of all, it's used in case of surface topographic characterizations which can be applied for hard dental tissues in special. Besides the topographic images, the atomic force microscope can be also used in force spectroscopy to measure the interaction forces and physical properties of the sample as well, which is actually considered a great advantage recently. Recently, it's actually using a specifically functionalized tips to study the protein unfolding folding mechanisms and recognize the molecular groups on a sample surface. Moving to the advantages of this technique is that it gives a minimal sample preparation. It's also requiring no conductive sample that actually may affect the preparation techniques. Also, it provides a three-dimensional surface profile, ability to image in the XYZ axes. It also works perfectly well in ambient air or even liquid environments. Also, it's possible to study biological macromolecules and even the living organisms. Due to its small size, it can be also used or combined with any other microscopes or instruments as well. Now, moving to the disadvantages of this technique, the first one is that it's not practical to make measurements on areas greater than 100 micrometers. Also, it's limited scanning speed, requiring several minutes for a typical scan. Also, one of the disadvantages is that the images can be affected by the nonlinearity, hysteresis, and also the creep of the piezoelectric materials, as well as the possibility of image artifacts that can be produced after that. And finally, the images produced by the atomic force microscopy doesn't actually reflect the true sample topography, but rather represents the interaction of the probe with the sample surface. And this is one of the greatest disadvantages of this technique. Now we reached the end of this presentation. Thank you so much, my dear professors, for listening. Hoping you enjoyed the information gathered in this presentation. Till we meet again, thank you so much.